right, children, we are on day 9. We're going to go over temperature, salinity, and acidification. Let's go over the temperature of the ocean really quickly. Bear with me as my slide loads here. Temperature. Temperature, there's 3 different zones within the ocean. First of all, the surface zone, that is our warmest zone that we have, that runs from sea level to 300 meters. And you might ask, why is it the warmest? Well, that's the zone that's exposed to the most sunlight. Sunlight only penetrates a few meters into the water. The wind and the waves mix that surface zone, so it is uniform throughout. It is mixed evenly, and it's the warmest layer that we have in our picture up here. So after the surface zone, we have the thermocline. That as the depth decreases, so as we go lower into the ocean, our temperature also decreases. Decline means to go down. Thermo means temperature. So our temperature goes down. This is a rapid change in temperature. This marks the area between the surface zone and the deep water, the deep zone down here. This thermocline is from 300 to 800 meters. Once we kind of get past the thermocline, we're in the deep water or the deep zone, and that goes from 800 meters to the bottom of the ocean floor. Our temperature starts to still decreases here because if we don't have any sunlight, and so it is very, very cold. It decreases, but not as rapidly, not as fast as it did in the thermocline up here. All right, so what is the ocean water? Our ocean water is only about 96.5% water. The other percentage is 3.5% dissolved gas, and it has solids such as salt. Sodium chloride, you might know as table salt, is the main component of the ocean. All right, so here we can see our beautiful little chart here. So we have water of this little sliver. So this is at 3.5%. It's made up of sodium chloride and then other solids, but mostly gas. We also have oxygen in there. All right, salinity. So we have ocean water and it has salt. So salinity refers to the amount of dissolved solids, in this case, sodium chloride salt, that's in that water. So the average salinity of our ocean water is about 35 parts per thousand. So that means that if we have 1,000 grams of seawater, about 35 grams of those are dissolved salt. And we have 50 billion tons of salt in our oceans. All right, so here's what our ocean looks like. So the largest amount of evaporation, of course, occurs in the surface zone because that's where the water is exposed to the sun. And of course, we know from the water cycle that when the sun strikes the water and it warms it up enough, we do what? Of course, you guessed it, evaporation. So as water leaves the ocean and evaporates into the atmosphere, all that salt gets left behind, which increases our salinity. Less water, more salt, which means it's more it's salty. All right. So what can decrease our salinity? Decrease how salty our water is. Precipitation, the melting ice, any runoff from the land, any addition of water will decrease our salinity. Any removal of water through evaporation will increase our salinity. So, how did the ocean become salty in the first place? Well, we have these things called rocks on our land. These rocks weather, and then the rivers erode the salts and all the minerals into the rivers. The rivers, of course, we know run into the ocean, and that's how we get all these salts from the land to the ocean. All right, once the water evaporates and participates in the water cycle, the water from the ocean, all that salt is left behind, and then the water returns back into the rivers through precipitation. So our oceans have actually become saltier if we compare them to when they were first formed. All right, so what can we do with ocean water? It's one of our resources. All right, we can do this thing called desalination. D means to, excuse me, D means to remove, salination, remove the salt, right? So we're taking the salt out of the water. So in these plants, especially for coastal regions, areas that do not have access to fresh water, what they can do is take the ocean water, which looks like this in this beaker right here. Take the ocean water and run it through some of these plants. What this factory is going to do is remove the salt so that you end up with fresh water. So it increases the availability of fresh water to these coastal cities or towns, which is really good, especially in countries where maybe these coastal areas wouldn't have any fresh water available to them. So more humans can live here, right? That's always a good thing. All right, so something bad that comes with having factories. Factories produce all of this smoke, correct? All of this carbon dioxide. They release carbon dioxide into the atmosphere. So the carbon dioxide is hanging out over here in the atmosphere, and usually what happens is that the carbon dioxide will get taken in by these beautiful, beautiful trees. Because we know, as Dr. Phillips said yesterday, plants and trees undergo a thing called photosynthesis. Photosynthesis is where they take carbon dioxide and water and produce what? Oxygen, which we love to breathe, and glucose, which is sugar for plants that they will then use to make energy. So what has happened is we as humans have participated in a thing called deforestation. So we've chopped down all our trees. So now that carbon dioxide from up here has nowhere to go. It can't go into the trees because we chopped them down. So where does it go? The ocean. All right, the bad thing about carbon dioxide going into the ocean is that it makes carbonic acid. All right, so carbon dioxide increases the acidity of the ocean water, which means that if there's more carbonic acid, then the ocean water is more acidic. That carbon dioxide, once again, comes from the atmosphere and goes into the oceans because oceans are carbon sinks, just like trees are carbon sinks. But remember, our trees were chopped down due to deforestation. Some organisms cannot live in such acidic conditions, therefore they die. All right, so as we can see here in this graph, our atmospheric carbon dioxide has increased. If you can see this here by the red line, it's increased from 1960 to about 2006, 7. And you can see here by this line that our seawater pH has decreased. So as we've gotten more carbon dioxide, our ocean water has become more acidic. All right, so why is the lowering of the pH, why is it bad to have an ocean that is more acidic? Well, it affects some shell formation. Here we can see the pH produces or allows these shells to form right here on the left. And then when you have a decrease in pH, you can tell the difference. They're not forming as nicely as they do on the left. And there's a disruption in their pattern. So you don't get these beautiful shells as you normally would. All right, so why should we care, right? We don't make shells. Well, it causes an economic loss. So the shellfish produce about 11 it's an 11 oh sorry excuse me it's a $10.5 billion industry. When there are no shells produced, this disrupts the income of some families and it disrupts their livelihood, so we lose money and it impacts